Hello, I'm Woody Wentworth of Skagit Valley College, also Ice Boat Marine. I teach HVAC, refrigeration, air conditioning, and heating here at the college. Today, we're going to show you the components and the basic process on how we would install a very simple refrigeration system on a 39-foot sailboat. This particular sailboat has a 6 cubic foot top-down refrigerator and a 3 cubic foot side-by-side freezer. Previously, the family that owned the boat had used ice. There was a 1980s vintage system. At that time, engine-driven and AC-driven compressors were very large, very expensive, big holding plates, and they failed a lot. And you turned your engine into a generator every single day, maybe twice a day in warm waters. Today's systems, and the system we're going to show you, is a lot less complicated, a lot cheaper, and definitely in the do-it-yourself category of installation. So King's Pride is going to get the system here on the table. First, we have a 35-watt compressor system. This one happens to be made by Vitto Frigo, an Italian brand. We chose that because we wanted keel cooled. This is the condenser where the refrigerant goes from a gas to a liquid, and water is about 8 times more efficient at doing that than air. And this particular sintered bronze, which really means don't paint it. You never paint this. You might have the diver scrub it, you might have to, when you get out of the water, they blast it. That's fine when you haul out, but you don't ever paint one of these. It loses its efficiencies. This outside the hull will be installed outside the hull. It's a through hull, and the refrigerant will come down to it. It'll condense and go back up and do its job at the evaporator. More efficient by far than an air system, not always necessary. In our cold Pacific Northwest waters, not necessary, but always nice. And it also eliminates another moving part, a fan. And the fan would normally be mounted here on this compressor system. And so you save maybe half an amp, quarter of an amp there in power consumption too. 12-volt system these are. You can get them in AC also, but there's virtually no reason to get AC/DC models, particularly on a sailboat with meager energy demands. Also on the table, we have the evaporator. And the evaporator is the working end of the refrigerator system. This is very similar to what you might have in your home refrigerator, built into the fridge. Here we're going to insert it into our ice box. So before I talk about that, I should talk about insulation. The key is about insulation. We have a huge amount of insulation going aft, up to 8 inches. This screwdriver didn't even penetrate all of it. We have insulation all the way around. Maybe we need a little bit more on the engine side where the freezer is going to abut the engine. But the top, the lid top, where it can leak and also sweat and lose some of its cold, is a little thin. So we're going to have to do something about insulation on top. Ideally, we want 3 to 4 inches, particularly in a freezer. The refrigerator could have a little bit less, but we've got a combined fridge-freezer. And I'm going to show you why they're going to be combined. So we could go with 2 compressors. We could go 1 compressor system, 1 evaporator system, a thermostat to regulate them for the fridge, and another for the freezer. But instead we're going to go with something called a pass-through fan. This is a thermostatically controlled pass-through fan. So between our fridge and our freezer, our fridge is 6 cubic feet, our freezer is 3. On the fridge side, we're going to put a hole with a hole saw. Roughly that's 2.25 inches, and it happens to be plywood. We're probably going to add another ½ inch or so of insulation to that barrier so we don't freeze our vegetables and melt. We're going to put a hole, and we're going to mount this on the refrigerator side. And we're going to run this cable back to any 12-volt supply. This thermostat, this dial analog thermostat, we're going to have to play with it a bit until we get the air coming, the cold air coming from the freezer, and get our temperature right. How are we going to regulate that? How are we going to know what's going on? Well, we bought an Amazon digital thermostat with 2 different sensors. One is going to go in the freezer, one's going to go roughly in the middle of the fridge, probably down around where the basket of food might be. And we're going to try to keep our fridge between 38 and 42 degrees, and we're going to keep our freezer You're not going to do it quite like at home, where maybe I have it set at 0 at home, but you're probably going to want to go 20 degrees or lower in the freezer, and so we're going to regulate it with that. And
that 20 is an important number for
that
me.
20 is an important number. Haagen-Dazs,
yes,
ice cream. Yeah, I have Haagen-Dazs coffee ice cream in my freezer right now, and I have a similar system on my sailboat, and that Haagen-Dazs is nice and cold. I have 2 compressors on mine because that's how the manufacturer built it. Slightly bigger than King's Pride, but that aside, I don't run my refrigerator compressor. I just run the freezer because I put in one of these thermostatically controlled systems. This one happens to be built, sorry, I have the wrong one. This thermostat is built by Frigoboat, and Frigoboat is an Italian brand. They sell systems very similar to this, also Italian, called Vitto Frigo, and these are 200 bucks. And if you get it tweaked just right, getting that 38 to 42 in your fridge and keeping the ice cream frozen in your freezer, it's a great way to go and saves you having to get another compressor system.
Great system. But you do need 2 holes though, right, in the freezer? You
yes,
gotta have in and out.
You also need a hole. You also need a hole above, so this would go roughly halfway down the barrier between fridge and freezer. You also want a hole up above it, maybe that far up above it, for the hot air to circulate. Hot, warmer air. Colder air on bottom, warmer air on top, so you get a circulation. If you don't, you'll be pulling air through the gasket of your freezer, and all of that fresh new air will be going by the evaporator over in your freezer, and you'll be getting way too much frost. It'll be frosting up every other week or so. You'll have to defrost. And I recently did my own boat the same way. So I had too much frost on my evaporator over in my freezer.
So Woody, for our students and our viewers, the evaporator part seems the most scary.
It is.
So how do you size it first of all, and then how do you bend and jam it down into that space?
So the first thing you want to do is you want to measure your boxes. Whether you have just a fridge, just a freezer, or a combination, the hardest of all to do, which is what we're going to do. So you measure your box spaces. And then you go to the Shore Marine website in Seattle. It's the best one I know of. And you go in there and you type in your measurements, and you get a cubic or a cubic foot measurement. In our case, we have 6 and 3. And then you go to a chart which tells you that roughly means you need a 12 cubic foot evaporator.
Wait. 6 and 3 is 9.
Yes, because you need twice as much evaporator for a freezer as you do for a fridge. It'll tell you that down below in the fine print. Thank you, Mike. So if I have a 3 cubic foot freezer, I double that and I get 6, and I've got a 6 cubic foot fridge, I add them together and I get a 12. So I want to look for an evaporator that will roughly give me that 12. More is better than less. So we actually went with, I believe it's a 14 cubic foot evaporator. Happens to be 10 inches wide by 41 inches long. You can see, or maybe you can't see, but I'm going to come a little closer, see if this works. We actually trimmed off a bit of this evaporator. It was more like this one. It looked more like this one over here. You can see now the gas comes in, goes through these channels. And so this part is dead space. So we cut off that much of it just to get it in the boat. And as long as you don't get too close to this channel, you're okay with that. So then the hard part is getting this thing bent and in there. That's the real work in doing one. And always be careful of this. You don't want to overbend this right here. Where the copper meets the aluminum is a special weld, and they're very delicate. So you want to be careful with that. Anyway.
What did we start with students? We can let the secret out. A cardboard template. That is not cheating, right?
So the first thing we did is we grabbed some cardboard. It's what I do. And we went to the boat and we cut our cardboard down to the right size. We bent it in there, very easy to do. And we marked it with some Sharpies where our bends were. We took it out and then we took it to our evaporator. We laid it out, got the same marks, and then it was about time to bend. So let me show you the way that it should look afterwards, and I'll show you how it shouldn't look afterwards. This bend here looks really nice. The radius is appropriate. We didn't kink the tubes at all. This one, It's fine. It's going to work just fine, but you can see it's a more of a sharp, acute radius here. And so we used too small of a tube over here. And I'm going to show you what we did. So we had some PVC pipes laying around the college. We also had a wooden dowel, and we used this 1.5 inches at first. It was me. I thought that's the right size. Well, it wasn't. And so we used an 1.5 inch radius tube, PVC tube, and we bent this one after heating it with a heat gun. So you take your heat gun without burning your paint, and you heat it up beyond what you can touch with your finger, and then you have somebody kindly lay down the PVC pipe on the flat evaporator, and you lift it into place. We went a little too small here. Now the formula is, let's say I wanted to come and I wanted my bend to be precisely at 11 inches. I get a wider, just believe me on this, go with something like this, about 2.5 inch PVC tube works very nicely. That'll give you a nice radius. So if this is a 2.5 inch, I would take 1/2 of that, 1.25 inch, and measure back on my evaporator 1.25 inches. And that's exactly where I would lay this to have my bend be in the right place, so that the back of the evaporator is very close to the back of the wall where I want to be. Now, this is pretty well covered in YouTube and also covered at the Shore Marine website. But if you get in trouble and you don't get it precisely right and you're off 1/2 inch here or there, these differences can be made up with spacers. And so you can go to the hardware store and buy white nylon spacers, 1/2 inch, 3/4 inch, 1 inch, or you can cut them to size. And so as you screw this in, we're going to have to make a couple new screw holes over here, but typically there are screw holes like there are over here, and there's 2 screw holes here on this part of the evaporator. When we screw it in, we're going to put a spacer for a few reasons. One, air circulation behind the evaporator. The back is just as important as the front to remove heat from the box. Secondly, expansion and contraction takes place in here, and we don't want it directly on a surface. And thirdly, when you're defrosting and all that, it makes it much easier to get the ice and what looks like snow out of there and clean it up, whether you're using water or you're using the hot pan method at the bottom of your fridge. So you definitely want some air circulation, and if you get your bend a little bit off by 1/2 inch, that's okay. You take it up the space with a spacer.
That's great, Woody. So I think we should go out and show them the installation of this, and then we can get the rest of the details on where all the compressor and everything else is going to go.
Yes. Now we went with a very simple plain vanilla thermostat, an analog thermostat, very simple, and another thermostat to separate the 2 units. So we're going to have 2 different thermostats. If we wanted to, we could have gone with a fancy digital thermostat, which is fine, but that's another topic for another discussion. But this one is the one that comes with the unit. And in case you're wondering what all this costs, roughly $1,200. Roughly $1,200 for a system that would, in this case, well, that's not true. This is a couple hundred more.
Probably.
$1,500 by the time you get done paying for tax if you're going to get a pass-through thermostat as well. Thank you.
Well, yeah, let's go install that evaporator.
Let's go film that, right?
Well, what do you got going on here, Woody?
So here's our condenser that we're going to mount on the bottom of the boat. The important thing is where to mount it is you want it underwater even when a sailboat is heeled over. So as close to center line as possible and not to interfere with anything else. So the evaporator, the condenser, and the compressor are all going to connect, and we'll show you later how to do that. But in the meantime, we're going to make a hole in the bottom of the boat. That hole matches up exactly with this 1.5 inch hole saw. Easy to measure that by taking the nut off of your through hole and sizing it off of your nut. And you want a little bit extra, right? So that's going to work very nicely right there. 1.5 inch hole saw.
Okay, what are you doing now, Woody?
So the proper way to unwind copper is to lay it flat on the ground and then run it out flat. It's a little harder to do with that through hole on there, but that way we have a nice straight. Copper has a tendency to work harden. If you bend it enough, it gets stiffer and stiffer, just the properties of copper. And so you want to try to get it as straight as you can
With never kinking it.
without a kink, and you just do the best you can. It is pretty soft at this point. There. And then you can have your way with it and just get it.
Hey, I'm gonna come and get them.
We're gonna get it up in there and then goop it, and Mike's gonna pull from the inside so we have a nice tight fit once she's gooped. Did I make holes not big enough? This is why I work alone. Good help is hard to find, you know. You know I'm kidding. Mike's the best. Now okay, Mike, you want to hold it there? Okay, great. I'll goop it up. Okay, there's my inside bead. Now I'm going to make an outside bead. Sorry, it's just coming out slow, Mike. All right. Now we have enough toothpaste on that. Okay, Mike, can you pull it up slowly? Boy, that's just gonna go. Jeez. Okay, let's see. What's that? Yeah, that's perfect.
But I just wanted to show off. There's the new, right there, came through, and the lines run up. And okay, Woody, that was fun, sort of. So we made good progress. You know, what happened to all your parts here?
It's always fun to work on boats, but things don't always go right, and that's because they're boats. So you can see we've got different sweater on, different day, different hat. So today we put the compressor on its platform inside the aft lazarette, starboard side. We got an evaporator in place, and we put the condenser on the bottom of the hull. Went pretty well. You've got some, you've already seen some of that on video, but we had a little bit of a problem. In putting that evaporator, that bent evaporator in place, I always warn people, be really careful. They are so delicate. Well, actually, they're not normally as delicate as this one was. We have to replace it. So just as I was giving the evaporator the last push through the hole that we had just made with the hose saw, and Mike was in the lazarette pulling the copper through, and I'm pushing it, I gave it one little push with the heel of my hand, and all of a sudden, it let out its ½ ounce or whatever it is of gas that the factory puts into those evaporators. And most brands you can get away with that, Nova Cools and other brands that I use, Dometics, but these Vitofrigo ones, right where the aluminum and the copper come together, it's an aluminum evaporator and the copper tubes, right there is where I tell everyone to be so careful. And I'm the one who let out the factory gas. So I've got to get another one. We're going to go at it again next week. We're going to bend it, we're going to get it in, and we'll be done with the job. And then actually there's still the thermostat to go, which is the one that will regulate everything. And then there's our pass-through thermostat, which I know you really want to watch because that's a specialty item, and I really enjoy doing those. And then we're going to hook the condenser, the evaporator, and the compressor together. We're going to give it some 12-volt power. By the way, it could be 24-volt power. They don't care. Same. And then we're going to make refrigeration. We're going to make magic. Thanks for watching. Stay tuned for part 2 when I do a redo on the evaporator.